So, hi, I'm Abby. I'm a PhD student at Wisconsin, but I'm presenting the research that I did during my master's degree with Andy Pablo, which is why the collaborators are all not Wisconsin affiliated. Because it is 9 p.m., my goal for this talk is to get you to read my paper instead of to explain my paper in full. So, my paper is called Anarchy in the Database. So, a survey and evaluation of database management system extensibility. So the first question is, what is extensibility? Extensibility is when the database system lets custom software extend its capabilities. So for example, UDFs would be a very classic example of an extension. You have a function, you're just like, you write it, and then you can just invoke it in a database system. DuckDB also has a fun little extension framework called the optimizer extension, where you can add different optimizer rules to the optimizer, and you can even use it to override parts of the executor, as Lawrence was mentioning during Q&A. And really, an extension is just an instance of the software. The rest of this talk will go over my research, and then we'll talk about how DuckDB stands up to the other databases in terms of extensibility. So, my research is 1, a taxonomy. I categorize different methods for supporting extensibility in databases because extensibility is not very well studied. The last time there was a paper on extensibility was the 90s, really, in terms of actually, there's some variants of we used extensibility to do this. That's common, but a paper on extensibility design itself is pretty rare, especially in the modern age. And extensibility has changed a whole ton. For example, DuckDB is doing a ton of stuff with extensibility recently. So the first step was to create a taxonomy, analyze the different types, the interfaces, and the tooling. The second step that I did is using my taxonomy, I analyzed a bunch of different databases, so 6 well-known databases, and then kind of just noted the types of different extensibility interfaces present in these databases. The next thing that I did was, now after I've done all this qualitative analysis, I did a quantitative analysis on all the database systems. I wrote an analysis tool to collect the information about the database systems and run compatibility testing. What is compatibility testing? Compatibility testing? Really simple. It's a smoke test. You download 2 extensions, you run their unit tests with both installed. Okay, we have a website, but it's only for Postgres extensions right now. And the question that I'm going to ask here and cover in this talk is, how does DuckDB stack up against the other database systems? So this is the competition. This is the other databases that I did a survey and eval on. The first of these is MySQL. MySQL's extensibility ecosystem, basically dead, except the storage managers. Those are pretty cool. MariaDB, same as MySQL. They've got a lot more storage managers and better documentation. SQLite got 3 types of extensibility. Only one of them is interesting. And the one that's interesting is the file system extensibility that allows you to overwrite the file system. The last of these is Redis. Redis had a really nice extensibility system where they only supported UDFs, but those UDFs could actually use Redis as an underlayer. So people were able to create really cool things like Redis Graph, which is a graph database for Redis, and Redis SQL, which is just a SQL interface on top of Redis. So this was awesome until in April 2023, Redis decided to market itself as a service and then deleted its modules page and stopped caring about extensions. A tragedy. And lastly, we have Postgres, which is arguably, people will say, is the database of extensibility, but I will later show that this may not necessarily be the truest thing. Alrighty, so the first part of my survey was that I identified 8 different types of extensibility. And DuckDB is in the far right, and as you can see, DuckDB actually supports a lot of different kinds of extensibility, which is really fun. The next part of my survey covers interfaces and tooling. So I identified ways that DuckDB interfaces with the database system. For example, DuckDB can add, or you can both adding and overriding components in the database is supported by DuckDB. DuckDB also has a lot of support for building extensions. So these are my DuckDB survey highlights, I would say, things that I really like about DuckDB's extensibility support. One, I think vectorized UDFs. This is the only database that had vectorized UDFs, where UDFs process batches of values instead of processing values one at a time. I also think that the way they supported optimizer extensions and I guess indirectly executor extensions is really cool, because you can add rules to the optimizer. This also places the role of like DuckDB as somebody who's like invoking the extensions as opposed to the other way around. I think this is the scanners, Postgres scanner, SQLite scanner. Those are really nice because you can see like the advantages of using modern C++ in DuckDB, where like you can actually just extend the catalog and then like overwrite the functions. And it's a very clean way of implementing an extension. I think DuckDB's got super good build and test tooling. They've got unit tests for extensions. They have an extension template. And lastly, they have a registry. And there's one point I didn't include. I do think the runtime extensible parsers. DuckDB has a new feature where you can extend their parser. And they will determine what syntax is extended at runtime, which is pretty cool. But DuckDB also has a registry. And this is awesome because it allows users to use extensions really easily. Alrighty, so this is my analysis. I'm not going to go too deep into this. This is the result of the smoke test for Postgres. And the result of the smoke test result in 17% compatibility problems. Like 17% of pairs fail. That's ridiculous. You're running unit tests. However, DuckDB has 0% compatibility errors. That's amazing. Okay, but there are 3 reasons for this, I would say. The first reason is only 4 out of 45 extensions when I ran these tests have state sharing interfaces. So this would mean like, there is an argument to be made that there weren't enough extensions that were breaking state compared to Postgres. Second is 2 things that I think are good about DuckDB's interfaces. One, language. I think writing in C++ has, and using managed memory, like C++ managed memory constructs, has a bigger advantage. And second, DuckDB invokes extensions instead of extensions invoking themselves. There were so many errors in Postgres that were caused because Postgres lets extensions invoke other extensions. And what happens if an extension decides to not play nice and say, actually, we need to go first, or we need to go last, or we actually just forgot to invoke you guys and now you don't work. And this was like a good source of the problem. So I think this is probably why there are no compatibility errors. But I will probably be rerunning these tests on DuckDB in like 5 years and see how it goes. Okay, oh wait, this slide doesn't have animation and this is really bad. But I think, but I will go over it. So if you can see at the top, the fun monstrosities in Postgres. The first one is PG version num. So in the top left corner, you can see if PG version num is greater than like 150,000. And this is like a version number for Postgres. And lots of Postgres code has encapsulations of like versioning logic. In fact, like there are some extensions with over 50% of their code in versioning logic, like in these if-def macros, which is like really hilarious. I also attached some fun errors of Postgres extensions. For example, like we found deadlocks. We found like, remember, there's a seg fault hidden underneath right down there. Database system is shut down. And the last error, which is probably the error that made me laugh the most, is when you run a password checking extension with another extension, they create a user and they say create user password, and then it errors out because apparently the password checker is also running. But this is actually a sign that it's working well. Both extensions are working well together. Okay, and that is the end of my presentation. So thank you.